How's everybody doing? Woo! Hope you're all having an awesome time at Unite 2015. Boston is my home for game development. I'm the tech director at Rat Dog Games. We're currently working on 2 titles, Dryker and Gunhilder. I've been in the industry for 14 years, and I'll spare you all the details of everything I've worked on. If you want to know more, you can, internet. I've been working with Unity since version 2 back in 2007, and I'm currently using it on the 2 titles I just mentioned. Dryker is a 2D side-scrolling action RPG, and Gunhilder is a 3D roguelike. Title of this talk is Applied Mecanim, Character Animation, and Combat State Machines. I'm going to start off by giving a brief overview of the state machine editor in Mecanim and Unity. And then I'll give you a real-world example of our player character, Rorik. I'll give you some details about the combat system and the event system in our game Dryker, and then I'll go through some enhancements, some tips, some ideas that I've developed and come up with since Unity 5 came out to improve our state machine design. So, brief overview. So this is what the Mecanim editor state machine looks like. I've circled a state. States are where the animations reside. So for this example, I'm going to say you're starting off in an idle state. So you'd have the idle animation in that state, and you might move into a jump state where the jump animation is, and you'd do that through a transition between 2 states. And transitions execute when particular conditions are met. Parameters are set by the code. So to go through the whole cycle, a player presses a button. The code recognizes that event. It sets a parameter. And when the conditions are met, as they would be if you were in idle and had a transition with a jump, when jump is true, you would end up in the jump state, perform the jump animation on the character. There's also layers in the state machine. Layers provide a way for you to control different areas of the character, or to layer animations on top of each other. I will show you more about that a little bit later. There's also entry and exit states that will help you increase modularity and sometimes reduce the number of transitions, mostly increase modularity. And finally, state machine behaviors. These are like little scripts that sit on the events, or sit on the animation states that, just like mono behaviors, you have an entry and an exit event, and you have an update per frame. It gives you access to the animator at that stage, and it gives you greater control over animations execution, effects, state, and events. So obviously, this player character is highly specific to our game, Dryker. I present it now as a real-world example. I'll show you the state machine, move on to the specifics of the combat and event systems, and I'll even show you some code. Lucky you. That's what he looks like. All right. Rorik's player character has 8 weapons, each of which has 9 to 12 ground attack animations, 5 aerial attack animations, 3 defensive maneuvers. Rorik has 4 throwable items. With throwable items, I mean like a bomb, bow and arrow. He's got a glaive that comes back to him. There's 6 classes of magic, each of which have 3 to 6 abilities, and that doesn't include any of the basic locomotion, jumping, hit reaction, dodging, dying. What that amounts to, let's see, there's about 150 weapon animations and states, 10 throwable item animations, and 30 magic animations, and 7 locomotion animations. And it sounds like it's just a couple hundred, but when you break down some of the throwing animations, some of the locomotion animations, you end up with up to 10 states for just one animation. What that results in, hundreds of states, thousands of transitions, very complicated state machine. So where do we start with that? Well, I started by watching the wonderful tutorials available at the Unity website. I've looked at other tutorials on YouTube, and I haven't paid for anything. I know there's some paid tutorials, but really the ones that Unity provides, I found the most useful. There's also several examples that you can find. Other people have posted their state machines. I found Okay. I found those particularly useful when getting started with this. Categorizing and prototyping also saved me tons of time. We're still in the process of, I'm still in the process of getting everything perfect. I've only got 3 of the 8 weapons in right now. It's because, one weapon has like 300 transitions, and then I later decide after I've wired them all up, oh, I want to do this a different way. Now I've got like 3,000 transitions instead of just a couple hundred that I want to change. This is the state machine for Rorik. This is the base of it. I've circled the unarmed locomotion. The move tree contains the idle, walk, run. Air tree is jumping, landing, and dodge is just a forward roll animation. I'm going to step into the combat tree now, which is right there. This doesn't have any animations in it. It's split up into just the different weapon types. I'm going to zoom in on the sword. And you'll notice right away that this kind of mirrors the base layer. We've got the movement tree, the jump tree, and a dodge tree. And this is so that we can have specific animations for walking with a sword. Instead of just walking like this, he's got a sword. So he might walk a little bit differently. He might jump a little bit differently when he's holding a weapon, especially for some of the other heavier weapons. We've got a couple really big, giant, heavy two-handed weapons. And also when dodging with a sword. I've also circled on here the combat trees. There's both grounded combat and aerial combat. So if you jump and you hit the attack button, you're going to end up doing something different. I'll just quickly step into the air tree, show you that. And you'll notice there are these states with X and XX. Those are the combinations in the X, and you might see a Y. Those correspond to the buttons on the controller. So there's 2 different attack trains, and they're on the X and Y buttons. If you hit the X, you'll transition to the X state. If you keep mashing the X button, you'll get to the next combination and the next combination to XXX. And these are all what happens when he's in the air. I'm going to step back out, and now I'm going to go into the regular combo sword. So I've circled 3 things here. 2 different paths for animations. One of them is, over here is the delay attack area. So you'd press the X button once, you'd wait, and then you'd hit it again, and it would go down that tree. That's controlled with animation events. So partway through each of these animations, except this one, each of these animations, there's a delay start event and then a delay end event. And if you press the button when you're within that window, it registers a delay press event, or a delay. It tells the parameter delay press, combo delay success, sets that to true, and then transition will happen to these animations. If you just keep mashing X, it goes down this way. So now I'm going to give you some details on the event system. Unity provides an event system with each of their animation import items. It works. It's a nice little timeline. I find it a little cumbersome, especially when I get to the 10th, the 15th event. We've got a lot of events. So I'm using a third-party solution called Mecanim Event System. I'm not trying to sell it. It's actually free. Somebody else made it. I just wanted to let you know what it is when I show it to you. That's what it looks like without the arrows. I put the arrows there for you. The yellow arrow, or let me get my dot out. So there's the X state, and you can see it's got 10 events in this state. There's the start event, there's a visual effects event, there's the combat trail start event, and the hitbox start. So combat trail event is thrown. So all of our attack animations have he starts an idle, he does an attack animation, and then he returns to idle. One complete animation. The combat trail event, would start up. So this is like a sword attack, like that. Up here is where the trail start event would happen. He's swinging down, hit start, swinging through, hitbox end, and then after that, there's a couple other events like move cancel, attack and cancel, and the delay box that I told you about earlier. And this demonstrates it nicely. So you'll see the player character, he's got him coming up, and right there's the combat trail event. It's a hitbox start, where damage would be done if there was a collision with an enemy. And then attack can cancel, delay start, move can cancel. So attack can cancel, move can cancel. You press the X button, character starts moving up. If you hit the X button again, you don't want him to just stop and do something else right away. So it has to wait until it gets to attack and cancel before it hits the next thing. So if you hit X and then X right away again, it'll hang on to that so that when you get to the end of the first animation, it'll start into the next animation of the combo. All right. And this is it in the game. That's the trail start event. And this is a little bit more of combat with all of that, with the trail in it. Little goblin. All right, time for some code. This is the combat animation state. It's the code side of the of in combat state events. So you saw that combat start event, combat end event. This is what receives those events, changes the internal state, and communicates with the character class code. So this is just an example. This onAnim event is what receives those strings. And this handle combo press manages that thing I mentioned earlier where combo success, right there. So if you're in the combo press, so delay start, combo delay press valid is true, and then if you get to this handle combo press and it's true and it sets combo delay success to true, which is sent to the animator parameters. And I'm just going to zoom in on those functions for you so you can see them. It's just setting the trigger for the combo success or the combo delay success, and that's setting the move can cancel. That's the end of the code for now. On to the enhancements. So I've got a couple things I'm going to show you. First, I'm going to show you some ideas that I've had, some ways I've been able to reduce complexity since I first wrote out everything. Then I'll show you an alternate organization that you might find helpful for keeping track of everything. And then I'm going to show you an experiment that I did, or the results of an experiment that I did, where I thought that I could get the generic and humanoid animations to work on the same character. And I will let you know how that turned out in a moment. First, reducing complexity. I found that the use of the any state was particularly helpful. One of the downsides of that, though, is that you're moving the transition logic out of the state machine and into the code. One of the nice things about these state machines is that you can put logic into them. So if you are in one state, there's only a certain number of states that you could transition into. When you move things into the any state, you lose all of that because anytime those conditions are met, you're transferring from the any state into that other state. And you've got to pay attention to what is a valid transition before you set the parameters which would cause that transition. But it reduces the number of transitions, which to me is more important because I've got hundreds and thousands of transitions. Along with using the any state integer parameters instead of bools or instead of even triggers, I don't know if you get, this is might be a bit of esoteric. Triggers are like bools, except they unset themselves. So if you set a trigger to true, it will set itself to false after the transition is consumed. So you can't expect it to, if you've got like a half-second transition, you can't expect it to immediately be false. You have to wait till the transition is completed, and then it will be set to false. Using an integer instead of a bool or a trigger works great with the any state. It allows you to avoid having transitions over and over from the any state, because oftentimes once a transition from the any state occurs, the conditions are still going to be the same a millisecond later, and it's going to see, oh, I'm in this state now, but the conditions from any state to this other state are true still. I'm going to start transitioning again. If you've got integers, you can immediately set the integer value or the condition that caused you to take that transition to something else so that it doesn't loop around and around again. So telling you about the advantage of using the any state. This is what it did for one particular area of our state machine. This was the bomb throw. And this is another example of, or this is an example of how I've split one animation up into 3. There's the wind up, and then if you keep holding down the button, he charges, and then he throws it. It's just one animation, but it's split into 3 states. And before using the any state, I have 11 transitions, and then after, it's just the 1. So more code. So state machine behaviors, one of the great things that this provides is a way to immediately set something to set that integer value to something else so that it doesn't keep taking it over and over. And it's just a little example of that. So on state entry, set the integer parameter to 2. And that's what this little enum does. 0 means that there isn't a transition happening. 1 is what tells the animator to trigger the transition. And then as soon as you get into as soon as the animation, as soon as the state starts, this script executes on state enter. It sets it to true, and you're safely in the state. This you might find helpful. It is a way to give the animator scripts, the state machine behavior scripts, access back to a controller class that's sitting on like the character. I've called it some component to make it generic, but it's in our character class. So the character class has the animator sitting on it, and at startup it tells, hey, animator script, give me all your give me all your SMB, state machine behaviors, and because they're all a base class, they all have this component, and I'm giving them all access to the character class. So an advantage, a reason that this is nice for us, is that if you remember from the timeline, the attack and cancel event is before the delay event. So if you're mashing the buttons, as soon as you get to attack and cancel, it'll start the next one. But if you don't hit it and you wait, you can still hit it all the way through the end of the animation. But if you hit it between the start and the end of the delay, it immediately transitions to the next animation, and it might not get the delay end. It might not reset it. And previously, I had all this logic in the code in our character class to try and figure out where we were in the animation state. Like, have we transitioned? Are we still in an attack state? Are we still doing the state we are before? And then when I detected a change, I would reset the value, which had to be done right away, because you can't have like the next state telling it that now we're in a new state, we're doing new stuff, and then the other state sends the combo end event, and then it resets everything again, which we don't want. So this particular script right here is set up to get to that exact point when you're leaving a state, is when you start to leave a state and enter a new state. Because the exit only happens when the state is completely finished, and that's happened after another state has already started when you've gone into the transition. So this alternate organization, this is a way that I've discovered after I wrote all that other stuff I showed you, a way to use layers in a way other than just using different parts of the body to mask out, like a top layer and a bottom layer, or facial animations. It uses a base layer where you put your locomotion, and then the next layer up is an overrides layer. You put combat actions. You can have multiple override layers for different weapons depending on your organization. And then an additive layer for things that you want to just get added on to everything else, an example being hit reaction. So he can be doing an attack, or any character can be doing something, and then they get hit, and they can react to it without having to just snap into their reaction animation. So this is an enemy state machine. I started off with a smaller version, because to make this change to Rorik state machine, would take a while, and I wasn't sure it was going to work. So I started off with this. We got the X and Y are just attack animations. And then this is what I ended up with. The base layer, all it has is the move tree. And the overrides layer, it has the attack values. And you'll notice here that the entry goes to an empty state. So this just kind of sits in empty state until you give it a reason to transition from any state to one of these attack values. So it'll just sit in the base, you hit something, and it'll transition into one of these attacks from the idle because it's overriding the idle more and more as it gets into it. And then when it leaves it, it goes to this nothing animation, and then the idle or walk or run or whatever shows back through. And then, as I showed you earlier, the hit reaction state, similar to above, it's got an empty state, any state transfers to the hit react, and then back to empty. The experiment. Okay, so as some of you may know, if you create a character, a player controller, or if you create an animator and fill it full of humanoid imported animations, and then you put one generic animation in there, none of the humanoid animations will work. If you have a generic one and you put in one humanoid, all the generics will work, the humanoid will not. So we've got a bunch of character animations that we're using. Since we're a small indie studio, we like to avoid hiring somebody to do all the basic animations like walking and running and dodge. So we want to use humanoid. And I thought, well, what if I put them in different controllers? Because you can have, they'll work if you make them all the same type. And I set that up at runtime, switched it, and it worked, sort of. I was actually surprised that it didn't make the character explode. But there's this little hiccup between them because I can't do a transition. I think this is the result, because the core reason that didn't work is because I wanted it then to do a transition from whatever it was in to this next animation state that was using a different type of animation, or even the same. Just changing controllers at runtime causes a little blip. And you can copy data over from one to the other. You can copy the time over the current state, but it was still a little bit of a hiccup. And after like a day or two of trying this out, I abandoned it. And I just wanted to share that all with you so that if you ever get that idea, oh, maybe I can do it this way. Nope, you can't. And that's the end of my talk. Do you guys have any questions I can answer for you? No? Okay. Oh, okay.
Hey, with your multiple layers solution, are you, so I guess when the additive or the other layers come in, like the locomotion is kind of like a zero weight, I guess? Mm-hmm. Are you still paying for any processing on those layers? Are they still being processed every frame?
That's a really good question. I am assuming that it's not going to be a significant performance hit. I think that's what your concern is, that it's going to be processing yeah. It probably is doing something on them. It's going through the empty state, but I wouldn't expect that it's that significant. The advantage to doing it that way, I think, outweighs the performance cost.
So the question I had is, could you elaborate a little bit more on why you're using integers in combination with Booleans as opposed to triggers in combination with Booleans to avoid issues with the any-state transitions?
Sure. So if you create a transition from the any state to another animation state, and you give it the parameter, or you give it the parameter, I don't know, let's say jump, and it's a bool from any state. Let's say you're in the middle of an aerial attack, the second combination of an aerial attack, and you press the jump button and it somehow gets set to true. Then you're immediately going to go and start playing the jump animation. And as soon as you transition, that's a kind of a different answer, but this should get to what you wanted. As soon as you've entered the jump animation, you're still going to have that value be true, like not with what I showed you with the script. Like if you've got that script there, you could use that script to set it to false. But then, see, I've got other code that wants to know when it's jumping still. So if I immediately set that value to false and the code wants to look at that bool and think, am I jumping? No, because that value is false. But if you have those 3 values, when you have 2, the code will know that you're still in the jump state, but the animator isn't trying to take that transition.
So my experience, though, is that you can also use a trigger in combination with a bool as sort of a gatekeeper. And I'm sorry if I misunderstood the answer, but I was just wondering, is there an advantage in particular to using an integer in combination with a bool as opposed to a trigger? Because my understanding is they both do pretty much the same thing.
Oh, I'm sorry. I wasn't proposing using a bool in combination with it. I was just proposing using an integer instead of either.
Okay.
So, yeah, a bool and a trigger together, you'd have 2 values as opposed to just 1.
Okay. Thank you.
You're welcome.
Hello.
Hi.
I just wanted to say that for the any state transitions, under the settings, there's an option to say can transition to self, and you can uncheck that, and then you won't have the situation where it stays set and it keeps going back to the same one. Is there a reason that that didn't work for you?
That's for the transition, right? Not the,
Right,
not the state. So that'll prevent you from leaving the transition in the middle of the transition and taking the transition again. But if you've exited the transition and you're still and the condition is still met,
No, I won't let you go back in. It basically says any state but that state. Like I've used that before, where basically you won't keep going back into that state. I don't think.
okay.
I don't know.
I've seen it loop.
It might help.
I've seen it loop from the any state over and over and over again, and I played with that setting, and I didn't see it immediately all go away. So there might have been something else going on. I will try that out
Just throwing
again.
it out there, maybe.
Thank you. All right. Doesn't look like there's any other questions. Thank you, guys.